All right, so we're going to use this last thing, that the expected value of a constant times a random variable is a constant times the expected value of the random variable, to figure out the expected value of the sample mean from what we know about the expected value of the sample sum. Okay, so we've been talking about pulling tickets at random. What? Okay, we've been talking about pulling tickets at random and adding the values on the tickets. That's the sample sum of n draws from the box. Suppose we pull little n tickets at random, and then instead of adding them, we average them. That's the sample mean. Okay? What's the expected value of the sample mean? The sample mean of n tickets drawn at random from a box is equal to sample sum of the n tickets divided by n, right? You add them together and you divide by how many you have. Okay? So that is, you can write it as 1 over n times the sample sum. Yes? That's a constant times the sample sum. So the expected value of the sample mean is that constant times the expected value of the sample sum. Right? That's this rule. Expected value of a constant times a random variable is a constant times the expected value. So the expected value of 1 over n times the sample sum is 1 over n times the expected value of the sample sum. Yes? Can I re-explain it a different way? What I mean by sample mean? Okay, so we've been talking about say a 0, 1 box. Okay, and suppose I pull 5 tickets at random out of the box. I might get the tickets 0, 1, 1, 0, 1. Okay? The sample sum is 0 plus 1 plus 1 plus 0 plus 1 is 3. The sample mean is 0 plus 1 plus 1 plus 0 plus 1 divided by 5. Okay? Okay, so suppose that I pull 5 tickets at random out of this box with replacement. Then the number of tickets labeled 1 I get is going to be random. On average, the fraction of tickets labeled 1 in the sample is going to be little p. The sum of the labels and the tickets I get is going to be little n times little p on average. That's the expected value. So the expected value of the sample sum gosh, my handwriting is just so terrible. I'm so sorry. So the expected value of the sample sum is going to be n times p. The expected value of the sample mean is equal to 1 over n times the expected value of the sample sum. which is 1 over n times np, which is p. So if the expected value of the sample sum of n tickets drawn at random from a box is n times the average of the number of tickets, n times the average of the numbers on the labels, the tickets in the box, then once I take n times that average and divide it by n, I get back the average. The expected value of the sample mean is the mean of the numbers on the tickets in the box. So the expected value of the sample mean is the population mean, population of tickets in the box. Does this make sense? Okay. And that's true whether I'm drawing with replacement or without replacement from the box. The expected value of the sample mean is still the population mean, still the mean of the numbers on all the tickets in the box. That's going to turn out to be very important. The sample mean in general is you add the labels on the things that you get in your sample, you divide by how many there were. In the special case that you're drawing from a 0-1 box, the sample mean is the percentage of ones in the sample. So the sample percentage is a special case of the sample mean when you're drawing from a 0-1 box. All you can get are zeros and ones. If the things are red or green, and you're interested in the fraction of red ones, then the number of red ones divided by the sample size is the percentage of red ones. Right? So the sample percentage is a special case of the sample mean.